No heat is needed to evaporate water. Just light is enough. New research from scientists at the Massachusetts Institute of Technology suggests that light can evaporate water without the help of heat. Researchers indicate that this effect is common in nature and may lead to new, practical applications. For millennia, people have observed the process of water evaporation, which transforms water from a liquid into a vapor. This is one of the most basic processes. Rivers, lakes and oceans are evaporating. This process occurs almost everywhere around us. It would seem that the evaporation we deal with every day is well understood from a physical perspective. However, a recent discovery by researchers at the Massachusetts Institute of Technology, MIT, challenges our traditional understanding of this process. It turns out that you don't need heat to evaporate water. Just light is enough. The description and results of the work were published in the journal, Proceedings of the National Academy of Sciences. A team of scientists from MIT, led by Professor Gang Chen, showed that it is not only heat that causes water to evaporate. Light falling on the water surface can directly release water molecules, causing them to evaporate into the air. This effect, called the photomolecular effect by researchers, occurs independently of heat, which challenges our beliefs. Because the observed effect was quite unexpected, the scientists conducted as many as 14 different experiments and measurements, collecting evidence of light-induced evaporation under various conditions to be confident in their findings. The key indicator, obtained in 4 different experiments, was the measurement of the air temperature above the water during evaporation in visible light. Instead of rising, the temperature stabilized, showing that thermal energy was not the cause. Other key indicators included how the evaporation effect changed depending on the angle of incidence of the light, the exact color of the light and its polarization. For example, the effect was strongest when green light hit water at a 45-degree angle. Even though water minimally absorbs this wavelength, 495 nanometers to 566 nanometers. The authors argue that this effect should occur widely in nature, from clouds and fogs to ocean and soil surfaces, and that it may also lead to new practical applications, including energy and clean water production. I think it will have many applications, Chen says. We are exploring different directions. And of course this also has implications for basic science, such as the impact of clouds on climate, because clouds are the most uncertain aspect of climate models, he adds. This astonishing discovery could have a wide range of implications. This may help explain strange measurements over the years that suggest clouds absorb more light than conventional models predict, thereby influencing climate change calculations. Chen suggests that the newly discovered mechanism could be responsible for this overabsorption, potentially improving climate calculations. It could also lead to new ways of designing industrial processes, such as solar-powered desalination or material drying. The research is based on findings from a year ago. Scientists noticed and described the photomolecular effect, but only in very specialized conditions. on the surface of specially prepared hydrogels soaked in water. In the new work, they showed that the hydrogel is not necessary for this process and that the effect occurs on any water surface exposed to light, whether it is a flat surface, like a body of water, or a curved surface, like a drop of cloud vapor. Scientists have determined that the photomolecular effect is strongest when light hits the water surface at an angle of 45 degrees. It is also the strongest with a certain type of polarization, the so-called trademark polarization, transverse magnetic polarization, and reaches its peak in green light. Chen and his colleagues proposed a physical mechanism that could explain the angle and polarization dependence of the effect. They suggest that light photons impart sufficient force to water molecules on the surface, displacing them from the liquid body. However, the dependence on the color of light remains a mystery that scientists believe will require further research. The discovery of evaporation caused by light rather than heat provides groundbreaking new knowledge about how light interacts with water, said Shulin Ruan of Purdue University, who was not involved in the research. This could help us gain new knowledge about how sunlight interacts with clouds, fog, oceans and other natural bodies of water. This has important potential practical applications, such as high-efficiency solar-powered water desalination. The results of this study belong to a small group of truly revolutionary discoveries that are not immediately widely accepted by the community, and their confirmation takes time. Sometimes a long time. He adds. The observations point to a new physical mechanism that fundamentally changes our thinking about the kinetics of evaporation, says Shannon Yee of Georgia Tech, who was also not involved in the research. Who would have thought that we are constantly learning something new about something as everyday as water evaporation? He adds.